Welcome to Podcast Learn and Fun. Let's start today's journey of learning. Have you ever been working on a problem and felt like you're stuck? Like, looking at it the wrong way?
Oh, yeah, all the time. Sometimes it's not about not having enough information. It's more like you need a new perspective.
Yeah, I know what you mean. So is there like a technique or something that can help?
Well, there's this thing called a Legendre Transform, and it's really all about changing your viewpoint.
Okay, now I'm interested. What is that?
You can think of it kind of like translating a sentence, like from one language to another. The meaning's the same, but the words change and the structure changes. You get a new way to understand the same information.
So you're not changing what's true, you're just changing how you talk about it.
Yeah, exactly. It's like switching between different ways to describe something. Like instead of talking about a car's speed, you talk about its momentum.
Right, they're related, but it's like different sides of the same coin.
Exactly. So the Legendre Transform helps you switch between those descriptions.
So it's about picking the right tool for the job.
Yeah, and it does that by looking at the slope, like how fast something is changing. That tells you a lot about what's going on.
Okay, I get the idea. Okay, can you give me a more concrete example?
Sure. Imagine a curve. Instead of looking at the points on the curve, you look at the slopes of the lines that touch the curve. Like if you were looking at shadows.
So you're getting different information from the same shape.
Exactly. And this is super useful for problems that involve energy or optimization.
Ooh, energy, like in physics.
Right. It helps us switch between different ways of thinking about energy in a system.
So it's like having different lenses to look at energy.
Exactly. Like internal energy, Helmholtz free energy, and Gibbs free energy. They're all connected, but they're useful for different situations. It's like having different tools in your toolbox.
So there isn't one right way to talk about energy.
Nope. It depends on what you're trying to do.
This is fascinating. It's like a decoder ring for scientists.
It kind of is. It helps you see connections you wouldn't see otherwise.
So can you give me a specific example of how it's used in physics?
Absolutely. In classical mechanics, there's something called the Lagrangian, which focuses on position and velocity. And then there's the Hamiltonian, which focuses on position and momentum. The Legendre transform connects those two.
But why would you want to switch between them? What's the advantage?
Well, the Hamiltonian is often much better for understanding how things change over time, especially in complex systems.
So it's like having two different maps of the same place.
Exactly. The Legendre transform is the key to switching between those maps. Okay, so let's say you have a function that describes the height of a hill.
Okay, like a real hill.
Yeah. And instead of looking at the height at different points, the Legendre transform lets you talk about the slopes at those points.
So like how steep the hill is.
Exactly. And that can be useful for lots of things.
Like what?
Well, imagine you're designing a hiking trail. You'd want to know where the steep parts are, right?
Yeah, you wouldn't want to send hikers up a cliff.
Right, so the Legendre transform can help you figure that out.
So it's like switching from a map that shows elevation to one that shows steepness.
Yeah, kinda. And you know what's really cool? It can also tell you something about how water would flow down that hill.
Wait, really? How?
Yeah, well, think about it. Water flows downhill, right? And it usually takes the steepest path.
Yeah, that makes sense.
So by looking at the slopes, you can figure out where the water's going to go.
Wow, I never thought of it that way.
It's all connected, and this is just one example. The Legendre transform is also related to things like convex analysis and differential geometry.
Whoa, those sound complicated.
They are kinda, but they're also super cool. Convex analysis is all about how curved a function is. Like a bowl is convex because it has one minimum point.
Like, so like a valley.
Exactly.
Yeah.
And a lot of real-world problems involve finding the minimum of a function, like if you're trying to minimize costs or energy use.
Right, you want to find the most efficient solution.
And convex functions are easier to work with because they only have one minimum.
So the Legendre transform helps you find that minimum.
It can, because the Legendre transform of a convex function is also convex.
So you're not changing the problem, just making it easier to solve.
Exactly. And differential geometry is all about smooth, curved surfaces. Like imagine our hill, but more abstract.
This is like a mathematical version of a landscape.
Yeah, kinda. And the Legendre transform helps connect different ways of describing those surfaces.
Okay, so it's like a universal tool for understanding both real and abstract shapes.
Exactly. And remember that thermodynamics example we were talking about?
Yeah, the one with the different types of energy.
Well, one specific example is the relationship between internal energy and Helmholtz free energy.
Okay. Remind me what those are again?
So internal energy is like the total energy in a system.
Like all the energy added up.
Right. And Helmholtz free energy is the energy that can be used to do useful work at a constant temperature.
So like if you have a compressed spring, not all of its energy could be used to lift something. There.
Exactly. Some of it's lost as heat.
Huh?
Helmholtz free energy tells you how much energy is actually available for doing work.
So it's like a more practical measure of energy?
Right. And the Legendre transform lets you switch between those two perspectives.
So you can go back and forth between total energy and usable energy.
Yep. And that's really useful for certain types of problems. Yeah. Because a lot of times you're dealing with systems at a constant temperature, like a chemical reaction in a beaker.
Right. So the temperature's not changing.
Exactly. And in those cases, Helmholtz free energy is the one you want to use.
Okay. So it's all about picking the right tool for the job.
Exactly. But, I'm curious, are there like any limits to this Legendre transform thing? Does it work for absolutely everything?
Yeah, that's a good question. Seems like magic.
Well, it's not quite magic. There are some conditions.
Wait.
The function you're transforming has to be well-behaved, mathematically speaking.
Well-behaved. What does that even mean?
Basically, it means the function has to be smooth, no sudden jumps or sharp corners.
So like a nice rolling hill instead of a jagged mountain.
Yeah, exactly. It needs to be something that calculus can handle.
So the Legendre transform likes smooth curves more than pointy ones.
You got it. But even with those limits, it's still a really powerful tool.
I'm definitely impressed. It's amazing how something so abstract can be so useful in so many different areas.
Yeah, that's the beauty of math. Sometimes you gotta look at things from a different angle to really understand them. And that's what the Legendre transform helps you do.
It's like getting a new pair of glasses. Thanks for showing me this.
My pleasure. There's always more to learn, but this is a good starting point.
Thank you for listening to Podcast Learn & Fun. If you like our videos, please subscribe, click the like button, comment, and share. See you next time.